I'm good to go? I think so. All right, I'm just going to start for the sake of time. Yeah, I think that makes sense. Yeah, so hi everyone. Thanks for joining us to think about oracles and Polkadot. I'm a little bit jet lagged, so hopefully this will all make sense and add up and be in English. So the problem we're going to be examining is something called the smart contract connectivity problem, or the oracle problem. This is the fundamental issue that the smart contracts people build today can't access data. So if they can't access data, they can't know what's going on. If they can't know what's going on, they're severely limited in what they can do. This essentially means that without access to data, all that smart contracts can do for the most part is move tokens around. Now, moving tokens around is great, and tokens are great, and that's all very exciting, and I'm a fan of tokens. But it would be really great if we could get smart contracts doing things other than tokenization. If we could get them talking to data feeds to trigger relevant contract changes about the delivery of something, about a market event, about an IoT event for insurance. And the fundamental issue, kind of the common ground that we need to have this discussion, is that there isn't right now any built-in functionality for that, and there likely won't be. And so what you essentially need is an oracle. Now, to put this in context, I think the space has gone through a number of shifts where the functionality of smart contracts on networks like Ethereum, soon to be on networks like Polkadot, that because the features of smart contracts have increased, they've evolved into doing more. I mean, that's essentially what we're talking about, is increasing what a smart contract is capable of doing. So to put that in context, I think it's just useful to look at how the evolution has developed so far. So I think the initial leap forward for smart contracts happened in the, obviously in 2009 there was a lot of progress with Bitcoin, 10, 11, 12, and then in 13 you had the appearance of the protocol opcode-based smart contracts. That's where you had to code into a protocol that you would have a decentralized exchange or an insurance contract or something else. So you couldn't write your own contract. You had to go to the protocol developers, and they had to put whatever smart contract you wanted into their protocol. So that was one very large shift. That's actually the shift that got me and a lot of people that have been in the space for 5, 6 years very interested in what smart contracts can do. Excuse me. The next shift was basically put forward by Ethereum. And it was a very large addition in features. It was a very large step forward in that instead of having to go to protocol developers, you could write your own contract. So contracts became scriptable, and you could script up whatever contract you felt you needed. Decentralized exchange of 50 flavors, insurance contracts, delivery for payment, whatever, payment for delivery, whatever contracts you wanted. So this was the next large shift that I think we as a community observed. The shift, just to kind of put into perspective what we're discussing, the next large shift in our opinion is a shift from scriptable contracts that can move tokens to scriptable contracts that can do everything else. So scriptable contracts that can send payments. They can, bank payments. They can know about off-chain events like IoT data for insurance. They can know about market events. They can, release data to people based on the fact that somebody performed some contractual obligation. They can, ingest identity data from off-chain systems so that somebody with the right identity can do something relative to the contract. So all of these multitude of basically off-chain resources, inputs and outputs, being made accessible to a contract will essentially exponentially expand what they're able to do. So we will literally go from moving tokens to everything else that a digital agreement can do, which encompasses all the financial services industries, trade finance, insurance, basically everywhere where you have a financial contract of any value. So this is the kind of body of work that we at Chainlink are focused on and that we're hoping to bring to many communities like Polkadot to enable those communities to build high-quality contracts. Essentially, our body of work is the creation of a middleware. Essentially, the creation of a secure, reliable oracle that can trigger contracts in various networks, Ethereum-based networks, Polkadot, various other networks, to both allow those contracts to react to relevant off-chain events and allow those contracts to generate off-chain events. So for example, a smart contract can trigger a shipment. A smart contract can start doing meaningful things the way that digital agreements do today. So, like I go to a lot of meetings. Like today, these days, that's what I seem to spend a lot of my time on with people that are building these contracts. And the reality is that the people who have already been building a form of smart contracts, essentially digital agreements, the people that have been building digital agreements in a centralized form, banks, insurance companies, fintechs, various startups, the digital agreement they have has all these capabilities. Their digital agreement running in some server in their bank, it can talk to data, and it can send payments wherever they need it to be sent, and it can affect whatever change they want it to affect. And this makes smart contracts not as attractive. In my experience, opinion, once that feature exists, the reliability of smart contracts makes them superior as long as they can also react to all the relevant inputs and generate all the relevant outputs. We'll get to the part about Polkadot and how we're integrating into that network and so on. But I think before we do that, it's important to understand kind of the usefulness of an oracle, what it could enable, and that fundamentally what we're doing with the Polkadot network and other networks is we're generating a collection of inputs that developers in that ecosystem can use in combination with their contract. So they can write a piece of contract code and they could have it react to data, or they could have it send a bank payment, or they could have it ship something, or they could have it deliver a pizza to your house, or they can have it do whatever they wanted that code to do, other than move a token. In order for us to actually deliver on this idea, it's very important that we're able to do it reliably, because fundamentally the value of a smart contract, the unique property, as far as I can tell, is that it's reliable. It's extremely reliable. It's so reliable that nothing can stop it. It's like it's super reliable. It's the most reliable form of digital agreement you could hope to have for a small amount of money, large amount of money, whatever contract value you have. That's a unique property. That's the unique property of our entire space, right? Bitcoin's unique property is that it's reliable. You have a private key, you reliably have a Bitcoin if it's tied to that private key, right? That means that all the relevant, like essentially mission critical systems, or the systems that are gonna affect what a smart contract does, also need to meet a high level of reliability. Because in my experience, actually implementing this for real use cases, people aren't as interested in a piece of a system. They're interested in a solution. They're interested in something that works end to end, right? If you talk to a CSO or a CIO or a lead architect, and you tell them, I have a great system, it works in the middle, but right before that and right after that, it's completely vulnerable. How would you like to use my system? It's not it's not as valuable. Assuming that CIO or lead architect wants to build something that reacts to data and generates off-chain events. So the real project of making a reliable oracle is the project of making a secure oracle, an oracle that can provide the same types of guarantees that a smart contract provides. One way not to do something like this, in our opinion, is to have a single centralized oracle that's maybe running closed source code, and which is run by some group of people that can just decide to basically either have that oracle go down, or it can easily be taken down. Essentially, that model is an example of a model that's incompatible with the logic of our space. The logic of our space is, why is smart contracts are fantastic? Because they're reliable. They're reliable because there's decentralized computation. There's multiple redundant nodes computing what a contract does. And that isn't the model of a single entity, a single node that's easily manipulated, easily shut down, easily DDoSed, easily manipulated, essentially. There's two sides to the solution to generating such a reliable oracle that we're pursuing and that we found to be the most likely to succeed in the near term. Essentially, the first solution is you apply the logic of our space, which is decentralized computation, to this same problem. So just like the smart contract is reliable because it's computed in a decentralized environment, the oracle mechanism is also computed in a decentralized environment. You have multiple nodes securing the contract state, you have multiple nodes computing the input of data, and then that also allows you to decentralize what data sources you use. So if you want to rely on multiple data sources instead of one, once you decentralize the middleware layer, then you have that option. Yeah, essentially, I have a very simple example that'll just put this into perspective. If you were paying somebody for delivery, you could have two sources of data proving that the delivery happened, one as a primary and one as a backup. And then when you wanted to calculate the payment amount, let's say you wanted to pay them in cryptocurrency, you would need a market price. And you would need a highly reliable market price, because if that was manipulated, then the payout to them could be excessively high. Or if you manipulate it, it could be excessively low. So in this example, you have multiple independent nodes querying multiple independent data sources, providing a decentralization of both secure middleware and data to allow a contract to be reliably triggered and allow it to gain reliable data that it needs to basically pay somebody accurately. And then there's a multitude of chain links that exist that can allow a contract to pay to various existing data sources, various existing payment sources. Essentially, yeah, the project that we're engaged in is the creation of this large collection of inputs. So the first thing we need is that they need to be highly secure. Ideally as secure as the contracts themselves, if that can be possible. And then ideally we want a large multitude of inputs that are pre-made. So just like web developers have APIs, which are essentially pre-made inputs and outputs, chain links or Oracle contracts on whichever chain the Oracle contract is on is a pre-made input, right? An Oracle is essentially a contract on chain that a user's contract can speak to, and it can request something, or it can request that the Oracle do something for the user's contract. So essentially the goal is the creation of a large collection of pre-made inputs and outputs that can be easily combined with all the code that people are writing in their smart contracts today. So we have been closely working with Web3 and thinking about how to best provide the various Web3 parachains with the relevant market data and other data they would need. And essentially, the way that looks is that there's essentially two stages. In the case of Polkadot, the first stage is every parachain. Let's say you have like a derivatives parachain, and you have a trade finance parachain, and you have an insurance parachain, and 5 other parachains for specific use cases where you get the scalability properties of these parachains or side, these linked chains. Chainlink can essentially broadcast a contract onto each of those chains. That's how the initial implementation will look. It will be, a contract that's broadcast to every chain that wants that data. You want market data. Let's say there's 50 chains. All 50 want market data about market prices, because they need that, because they're chains that have on-chain financial products. 50 Chainlink contracts get broadcast, one on each chain, and all the contracts on each relevant parachain can then use its respective contract. This is an immediate solution. It gets people off the ground. It gets them building. Essentially, our company exists to do that. Our company exists, our body of work exists to enable people to build genuinely valuable smart contracts that go beyond tokenization, that react to and generate useful events. The second, later implementation would essentially be the creation of a once enough usage starts happening on the relevant chains, and you possibly have scalability concerns, then you can generate a parachain, essentially an oracle chain, a chain where there's reliably a way to acquire data, both reference data and specific data, that the other chains can query. So if a large number of parachains begin using the same data, at some point the scalability approach of Polkadot might be useful as far as generating a chain specifically for the input of data into the other chains in a more scalable way. Those are essentially the first two phases. The first phase is essentially, able to work pretty much right away, and something that we can, we're looking forward to people using and people gaining the benefit of being able to build something truly useful. So, yeah, that's the overview of the problem. Our solution, one part of our solution, that's the decentralized part. There's another part to our solution where we use trusted execution environments, like Intel SGX. And for that, we acquired a project called Town Crier, which was made by some of the leading academics, and has been, as far as I know, the only Intel SGX kind of TE production system that hasn't been breached for delivering data to contracts on mainnet, at least specifically using Intel SGX. But I don't think we have enough time to go into the trusted execution environment piece. Essentially, I think the important property for more publicly focused platforms or networks like Polkadot is the ability to get data in at all, and then the ability to get data in a decentralized form, which matches up with the security model and the thesis of the network itself. Yeah, I'm kind of a little jet lagged, so sorry if my voice is a little kind of monotone. I've just been kind of recently flew in, and I tend to go on. So I guess I can do questions now, because if that makes sense, if there are questions. Seems like there's a few questions. Yes, right here.
So that's the input side that you covered there. Can you tell us more about the outputs? Like, I'd love to have sort of an example of a smart contract ordering a courier shipment or something like that. Is there?
Yeah, like a silly example is imagine a smart contract could use some kind of delivery API to order a pizza to your house. Like, because now you can pay for the pizza using Bitcoin or something. That's a silly example. A more useful example is, let's say you make a smart contract in the insurance industry and you want to pay out premiums. And the people that would receive your premiums, well, not the premiums, but the payout from the actual insured event, and they want to receive it in dollars or yen or some fiat currency. The smart contract needs a bridge to send those payments in a traditional format.
Yeah, so is there any work on that yet, or any examples of how that can be solved?
Yeah. We have something called the core adapter model. So we have core code, which is the code that reliably secures the main operations of a Chainlink node. And then we have adapters. And adapters are integration level code that are written around APIs. So I think we have a few adapters built around existing payments networks. They require people's credentials, and they require people to basically permission the Chainlink node to use their account. But essentially what we have in terms of Chainlink is a very flexible system for adding various payment sources. You basically just write adapter level code to that payment source's APIs, or in the case of banks, Swift messages, or in the case of somebody else, some other standard. And that means that the contract can generate a payment in that system. And
that code runs where? Are you talking about Solidity code that runs as a smart contract, or are you talking about something that runs on the outside?
In the outside. So this is essentially middleware. Middleware sits in both worlds. So it sits on the on-chain world in the form of a contract, and then it sits off-chain in an off-chain piece of software that essentially monitors that contract and executes the commands sent to it. So the on-chain contract is like an interface that other contracts can talk to for a specific resource.
Okay, and then presumably that's a bit more of a challenge to decentralize than, say, the inputs, which is more sort of data.
Yeah, that's
can
more
be
of a
decentralized.
challenge.
It's like quite difficult to imagine decentralizing.
Yeah, traditional payments.
Wire payment or something like that.
That's a different challenge. The challenge there is being able to do it at all.
Yeah.
Going from 0 to 1.
Yeah, or maybe having some sort of competition so it's decentralized through a competitive structure.
Yeah, traditional payments have a lot of regulation and a lot of things that you need to jump through. So getting from 0 to 1 is already a big step.
Yeah, I'm not thinking actually about payments. I'm thinking about, could be anything like ordering a courier or dispatching something or...
Yeah, you can...
Yeah, but I guess that's
there's systems where you can generate a payment, then you can have other chain links confirm that a payment was generated, even though if they don't generate the payment. So things like that can happen.
Okay.
But I think there's other questions, so I'm just
Cool,
gonna...
yeah.
There's a fellow here right behind you.
Hey, thanks for the talk. I was just wondering if you have like a decentralized oracle, meaning distributed sources of truth, looking at the same source or like multiple versions of the source, say a price feed of a single item picked up on different markets. What's kind of your strategy to uniform this into like a single value, and how does that not get biased by, for example, an attacker that puts in like a huge bias to this?
Yeah, so that really depends on the use. Sorry, I should do this. I've been told I should do this. I should repeat the question. Essentially, the question is, how do we decentralize the origin? How do we make sure that the origin of the data provider, whether that's a data company, an IoT device, or whatever, how do we reliably eliminate the risk that that's tampered with? Is that?
Well, yeah, you have multiple sources coming in.
Right.
And then the question is, that's kind of a statistical distribution of data, and how you do it, right?
Right, so then what that comes down to is what people are willing to pay for decentralization on the level of the origin, and if they can even have a decentralized origin. So in certain cases with IoT devices, like let's say I'm looking at temperature, and I'm looking at temperature in some geographic area, or I'm looking at some kind of weather event in a geographic area, and I have multiple sensors, or I'm looking at a field of solar panels that I'm insuring, and I want my contract to know how many solar panels are failing. I have a multitude of sensors, right? So then I can take a subset of that distribution, and I can randomly query, 50 solar panels, and if all 50 work, then there's no problem, right? Then the contract doesn't pay out an insurance amount. But then if it's Chainlink is part of an architecture. So essentially, there are different design patterns for different contracts. And those design patterns depend on how much people want decentralization, whether they can even get it based on the data source. There's just a number of factors. Essentially, what we're seeing in practice is that there's, for different use cases, like derivatives, there's many sources of market prices. So the design pattern is, let's get multiple data sources. For IoT-based insurance, where there's only one source of data, the design pattern is you're stuck with that, right? there's no like clear-cut answer. It's just, I think the key idea is that the important thing is that we provide people a flexible, secure system to choose the design pattern that secures their contract. That's essentially the body of work that, in another, I have like 6 ways to describe what we do, but that's another way to describe it.
Any other questions for Sergey?
Okay, looks like there's one more.
Thanks. Hi, how does the Chainlink technology aims to be blockchain agnostic?
Yes.
You're specifying the Polkadot network in this talk, but it also works in the others blockchains, other examples. What is that a core code which is?
Sorry, could you speak louder?
What makes the Chainlink technology blockchain agnostic?
Oh, yeah, sure, makes sense. I think everybody heard the question. I've been told I have to do this, because otherwise I just start talking and nobody knows what I'm talking about. Essentially, how does Chainlink become blockchain agnostic? It's the same answer as I gave earlier, sort of. There's this core adapter model. So the core features are these security reviewed, audited, open source security features that every reliable Oracle will need. And then the adapter level code, so there's adapters for Hyperledger, there's adapters for Zcash, Bitcoin, and people in the relevant communities can also write their own adapters, right? So the whole goal for us is that there's an easy way for you to gain access to a large collection of inputs. All you have to do is either ask us or maybe somebody on your team, or usually through some kind of collaboration like the type we're having with the Polkadot network in Web3, we arrive at an adapter that enables your chain. And right now, I mean, we're able to turn those around in like something like a day and a half. So our goal is to make a flexible system where, well, it also depends on the chain. It really depends on the chain as well. But essentially that's the answer. The answer is a flexible system where literally, every chain out there, if you wanted your chain to have all these inputs, all these data sources and all these payment sources, all you had to do was to write an adapter. And that might take, day or two or a week max, something like that. Yeah, okay, sounds like I answered it. There's apparently another one, okay. No worries. That's cool, so the people that ask questions get a t-shirt. Now I'm wondering why they're asking the question. No, I'm just kidding. Yeah, hi.
So something I was wondering while you were explaining how you make Chainlink decentralized, do you guys make any assumptions on the integrity of the data that passes through Chainlink, or do you just assume that it's genuine and correct?
Yeah, so there's a number of approaches to this. I didn't have time to get into trusted execution environment approach, but essentially, well, actually, let me make sure I understand your question. Your question is, if the data source tells, for example, 3 chain links that the value is 1, then those 3 chain links will all accept the value as 1. Is that your question?
My question is more along the lines of, what if you don't have enough sources to actually verify that, I don't know, the price of Bitcoin is $8,000. If you just have like 2 or 3 values, do you just pass them on as correct, or do you modify the values in some way to determine which is the correct value? Do you have a reputation system?
I think the question is, what if I don't have enough data sources? What if I don't have enough origins to create a reliable degree of decentralization? Does that sound? Yeah. So that's, if you don't have enough data sources to create the level of decentralization at the origin that you'd like, that's a problem. So in the case of market prices, that's not a problem. There's a multitude of market price data feeds and indexes. So in that example, it's not a problem. In other examples, it may be a problem. There may be a situation where you have a single IoT device, and you're stuck with that one IoT device. But then you can get into all kinds of other dimensions of security, such as maybe the IoT device has a secure environment chip, right? Maybe it signs something, and then that signature is verified in the Chainlink's trusted execution environment. So there's a few approaches that you can dial up and down depending on your situation. In the single source, it's likely that the trusted execution environment is going to be more useful. And it seems like there's another version of the question. Yes.
I don't have a mic anymore.
Yeah.
I can hear you.
Maybe Sergey will be around after this. Yeah, we have to go on to the next talk.
Yeah, I'm glad. I think about this a lot, so I'm glad to talk about it right after, if you'd like. Thank you. Thank you very much.
Thanks a lot, Sergey.
Thanks for having me. Thank you.
Okay, so next we're going to hear from Sean.